Okay, so 6.1 is antiderivatives and integration. Okay, notes. Okay, so function capital F is an antiderivative of a function. Oh, I'll change the due date. Thanks for letting me know that it's set for tomorrow. Make it next weekend on the homework. Okay, back to this. All right, this is an antiderivative of function lowercase f if for every x in the domain of lowercase f, we have capital F prime of x equal to lowercase f of x. Okay. So I put a note here. I have if f of x is an antiderivative to capital F of x, okay, I'm just gonna erase this part. Okay, so capital F of x is an antiderivative of f of x, then f of x. Okay, c is a real number, c is a constant. C. Okay, so I have an example. So we have capital F of x equal to x to the fourth. And we're going to have capital G of x be x to the fourth plus 2. Okay, so the antiderivative will have the form, let's see, I put all antiderivatives have a form of, put f of x equal to 4x cubed for lowercase f. And, oh wait, all antiderivatives, erase a little bit, sorry. Do we divide by 3? We're gonna get there. So we have to first get the function. Okay. X to the fourth plus c. Okay. Make sure I have this all correct. F of x and g of x. And so this is an antiderivative. So is x to the fourth plus 2. And another antiderivative of lowercase f of x could be capital H of x being x to the fourth. Could have like minus 1. Okay, let's move on. So we're going into indefinite integrals. Okay, let f of x be a function. See, if it's a function, let capital F of x be any antiderivative of lowercase f of x. Okay, got a setup, and now we have your notation is an integral sign. So you've got the integral of f of x with respect to x dx is equal to capital F of x, the antiderivative, plus some number c. Okay, this means that I have f, capital F prime of x equals lowercase f of x. All right, I have some examples. So first one, the integral of secant squared theta d theta. So we talked about the derivative of tangent was secant squared, so your antiderivative for secant squared will be tangent theta and then plus c. All right, I have the integral of 5 dx. Have 5x plus c as your antiderivative. So just make sure that if you took the derivative of this side, you would get that function right here, or in this case, just the number 5. Okay. I have some integration rules, which someone kind of mentioned just a second ago, but we'll put the general rules down and then more examples. Okay, first one, the integral of any number. Well, let's introduce the number. Okay. All right, first one is the integral of k with respect to x is, what do we have, kx plus c. Okay, c is some number, some real number. Number 2, the integral of k times f of x, some function f, is equal to k times the integral of f. Okay, the integral of f of x plus g of x, so if you have two functions added together or subtracted together, so let's do f of x plus or minus g of x. Like this. Is going to be the integral of f of x, then you add or subtract the integral of g of x. Okay. Another rule is the one that was mentioned earlier, number 2, do we add c? If I forgot to add c, then yes, we were supposed to add c for the antiderivative. Thanks for the comment. Last rule is when you take the integral of x to the n dx, you will have x over n plus 1. X has a power of n plus 1. And then add c. Side note. N does not equal 1. Sorry, negative 1. You can't divide by 0, so this cannot equal negative 1. Okay, examples. First one is the integral of sine of x plus x plus 7. So when you want to start the problem, either mention it or type it, first part. Yes, negative cosine x, thank you. Next part, anybody? Or actually it's difficult to type. Okay, we'll have a power of 2 and over 2, x squared over 2. Nice. Add, what's this? 7x. Oh, that would be if you took the derivative, you would get a 0, but we're doing the antiderivative, so we need a 7x. Yeah. And then plus some number c. That's the whole thing. Okay. This time, got the integral of sine of 2x over the sine of x dx. Okay. Trig identity for sine of 2x will be 2 sine x cosine x. This all over the sine of x. Okay, when we put in our x values, this sine of x over sine of x will reduce, and so we'll have the same number for 2 times cosine of x. The integral of 2 cosine of x dx. And if you want to bring that 2 over here, then have the integral of cosine of x dx. What's the final answer? Somebody? In the chat? Anybody? No? Yes, negative 2. Negative? I have a positive 2 sine of x. Let me make sure. The derivative of sine is, oh, okay, we're good. Okay. I think we're right. Next example. Okay, integrate this whole thing here. In the numerator, it's going to have t squared minus 3t minus 5. sorry, plus 5. Denominator has the root of t. All right, let's rewrite what's in there. Integral of t squared minus 3t minus 5 t. Okay, split this up. T squared over t to the 1/2. 3t with this power 1 here. 1 minus 1/2. Minus 5 to the 5 times t. Oh, actually, I keep doing this. Plus 5t negative 1/2. Yeah, plus 5. I'm making that mistake. So we're going to finally do the antiderivative. We'll have to add 1 to 3 halves, so you'll get 5 halves in the denominator. T with power 5 halves. 1 plus 1/2 will be 3 halves. And then 5 times t with a power of 1/2. Plus c. And we want to make this look nice, so we'll multiply by the reciprocal, and that'll be our final answer. All right, 2/5 t to the power 5 halves. Subtract. When you multiply by this reciprocal, the 3's will reduce, and you have 2t power 3 halves. And this will be multiplying by 2, and you get 10. T with 1/2. Okay. So I have notes about how these integrals and derivatives undo each other. So first part is like this. Differentiation is the inverse of integration. And the symbols look like this. Let's see, I've got the derivative with respect to x of the integral f of x dx is equal to f of x. So the derivative along with the integral leaves the function f of x. Okay, I think we'll start the next note right here. And it's that integration is the inverse of differentiation. guys a second if you still need that part. Okay, how we'll write this part is if we do the integral of f prime of x with respect to x, you get f of x. So the integral of the derivative will leave the function plus c. Cool. All right, we're getting closer to the end of the section. So the next definition, or kind of the next part of this section, is about differential equations. Okay, differential equation, dE, is an equation that contains derivatives. Okay, so I want to add some homework that will help you to find particular solutions to differential equations. And then for notes, we'll write it up as steps. So steps to find particular solutions. To DEs. Okay, start the steps. Okay, so you'll be given a differential equation. And initial conditions. We'll talk about that in a second. And initial conditions for a specific value of x. Okay. Given a differentiation and initial conditions for a specific value of x, first thing you do when you're looking for this again, particular solution. You get a general solution by integrating the dE. So we'll start there. Integrate the dE. Okay, so you're going to get a general solution. Number 2. Use the initial conditions. To solve. And then I guess you could put a reminder as number 3 that you do write the final equation at the end. So number 3, substitute C to get the particular solution. Okay, got one example for now. And I don't know, maybe we'll have time to do another example. So our differential equation okay. Oh, let's see. How can I summarize this? We'll let f of x equal 2x minus 2. Then the initial conditions are f of 1 equals 2. So at that value, x equals 1, you have an output f of 1 equal to 2. Okay, so you know what x is, you know what f of x is, and we integrate. I guess we want to ask the question and then go through the steps. Find the particular solution that satisfies the DE. Okay. So we'll do we'll do them in those steps. First part is to integrate f prime of x. Okay, the integral of 2x minus 2. Oh, I forgot to put this, that this was the derivative. This is a or okay. So this is your differential equation. Derivative of y with respect to x, or f prime of x, equals 2x minus 2. And then we integrate that part. Someone want to start this? Um, 2x minus 2, 2x minus 2. Thank you. Okay, yeah. I've got, okay, 2 times x with a power 2 and then over 2, which would leave this x squared, which I think someone posted, right? Let's try that again. Hang on. doing all the little steps, make sure you don't make a mistake. So we had this here, x power 2 over 2. And then don't forget that number sign. Minus 2x. Yeah, those twos reduced, and x squared is left over. Okay, just check it. Squared is f of x. All right, I have a note that this part is called the general solution when you don't know what c is yet. Okay, we're going to solve for c. We know that use x equal 1, then f of x equals f of 1 equals 2. Okay, let's flip this around. So f of x is x squared minus 2x plus c. When you put in 1, you get out 1 squared minus 2 times 1 add c. You're told f of 1 equals 2, so just substitute f of 1 2. And then 1 squared will be 1. 2 times 1 is 2. And you're trying to solve for c. So 2 equal to negative 1 plus c. Before finishing that, like, you're not quite done yet. You have to put in c to that function, and then you're done. So we had f of x equal to, what was it? X squared minus 2x plus c. X squared minus 2x plus 3. Okay, where are we? There's 10 minutes left. I don't want to rush. We can spend some time next week finishing 6.1. So we'll do more examples with DEs, and then we'll do some application type problems, and then we'll start the next chapter. So thank you, everybody. Stay if you have questions, but other than that,